Hey everyone, my name is Sylendran. Thank you for taking out time to go through this presentation. Today, we'll be diving into a fascinating yet a crucial topic on evaluating gender bias in machine translation. Just to give credits to the writers before we proceed, this was a research paper published by Gabriel Stanowski, Noah A. Smith, Luke Jettelmoyer in about 2019, right, about 5 years back. And just for the sake of this presentation, I will be role playing as the actual researcher in this case, as if it was my paper and my work that I'm presenting to a certain group of audience, just for the pure sake of this presentation. So let's get into the slideshow mode. Right? Imagine your machine language translation systems not just inaccurately translates what you're trying to say, but also introduces gender bias and stereotypes into your translated statements. That's not an ideal system that you want to have in place. Language translators are a channel to global communication, and we want to ensure that they accurately translate what you actually intend to say. So this paper goes on to evaluate the gender bias that exists in machine translation systems as of 2019. So let's look at what we have for our presentation. So there are 6 topics in the agenda. One is we start off introducing the exact phenomena that we are trying to study in this case. The second one is calling out the real motivation based on the impact this gender bias and stereotype in translations could have on just the society. And we go on to devise a bias statement and lay out an ideal data set distribution on what should be a good, accurate translation system be like. And then we throw light on the methodology, on the research work itself, the core research that was carried out. We identify and lay out a few metrics to track the results, and we also spend some time understanding what each of the results mean. And lastly, concluded with the limitations of our work today and the related works. And we go on to lay out what could be a good ideal future work to pursue, right? Yeah. So this was one statement that came into my mind, and I came up with this quote for this presentation. So humanity has begun dismantling stereotypes across all walks of life. It's only imperative that our missions evolve alongside us, embracing this progress, right? In 2024, even right now, we are talking about inclusivity, diversion, and breaking stereotypes across every single facets of life. And it's high time that our missions also embrace this, right? So let's start off. What is the real objective of our research paper? It's to identify and evaluate the level of gender bias that exists in machine translation, the language translation systems today. So the exact phenomena that we're trying to study in this case is, for example, if you're looking to translate, the doctor asks the nurse to help her into Spanish, let's say using Google Translate as an example. The translator gives you this back. El doctor le pidió a la enfermera que la ayudara. So in this case, the doctor, which was gender neutral, and the nurse, which was gender neutral in the original English statement, is now being translated to a male doctor and a female nurse. That's mainly because of the old norms of gender stereotypes with professions. And that's been carried on to the models that exist today. Right, so we're trying to understand how much of this gender bias exists in each of these machine translation systems. So why this work? Why are we trying to understand this problem space more? Because of the impact it has, right? So first of all, it sort of questions the credibility and trust on the translation systems itself. Millions of users out there are using these translation systems, and there are inaccurate and stereotypical references and co-references that exist in the statements, which sort of questions whether are they even truly reliable. And that's just one aspect of it, right? The second one is it starts to perpetuate stereotypes, influencing large societal perceptions, right? Which could further down the line act as barrier to inclusivity. If you start associating roles with certain stereotypes and next generation starts to use these machines, it's going to act as a societal barrier for making step forward on the inclusivity and diversion piece. So what's the current state? Despite all the advancements that exist today, our popular MT systems like Google Translate and Microsoft Translator still exhibit gender bias. So let's study what's the extent of it. Before that, let's clearly devise our bias statement for this research. The issue here is that gender bias in machine translations not just reflect but amplify societal stereotypes. Thus, it's skewed towards inaccurate translations. So in an ideal world, our data set or data distribution should be a balanced data set that accurately presents all genders in various roles, just like the image that you see here. The gender really does not define what profession you want to carry out in your life, does it? Yeah, that's how we want our systems to behave as well. So before we went on to understand the research work that we need to put in, we studied some related work, primarily under two domains. One was co-reference resolution. The other one was studying the machine translation systems. The co-reference resolutions, there has already been research work, for example, by Vino Bias and Vino Gender. Yeah, they went on to identify the gender bias that exists in co-reference resolutions. So in an essence, co-reference resolution is about studying the gender and the association of various entities that exist in a particular phrase or a statement. For example, the pharmacist asked him to pick it up. So what is him referring to over here is something that co-reference resolution systems should take care of. So there are other studies that we went on to read about. I'm not going to be covering each one of them in this presentation, but they are a nice read for sure. So in terms of machine translation systems, we studied about the persistent gender biases that's been called out in multiple qualitative studies. The primary takeaway from this research or reading was that the previous work all lacked comprehensive evaluation metrics to quantify, especially on large-scale data sets for robust analysis. Second one is, there is really no large-scale quantitative evaluation that existed prior to this work, and that's the motive behind our work. So before we talk about the methodology, let's identify what was the data set that we prepared for this work, right? So we further extended on top of the Vino gender and Vino bias data sets. We concatenated both of them and called it a Vino MT data set, and which had around 3,888 instances, which was quite balanced between male and female references and roles, along with stereotypical and non-stereotypical occurrences of those roles. Right. And the database mainly has these two types of English statements. For example, the type 1, the entity is being referred to later in the statement, and then the other one where it just exists immediately following it. That's been broadly the two types of data sets that exist. Now, what's our primary research method? First, we translate the VinoMT English sentences to language, a particular language L, using a particular model. The model in this case is a machine translation system that we are trying to study. So once it's translated, we align it with using fast align technique. Again, there's a research paper on how this is being carried out, but the primary goal is to align the English entity annotated in the co-reference dataset to the translation that it yields us. The last step is to extract the exact gender that has been formulated by the translation system in the target site, right? So we use off-the-shelf techniques to extract the target site entity's gender in this step. Now that we have talked about the method, what is an experimental setup like? So we talked about the data set. Now the next thing is we analyze 6 different models, right? So the empty models that we analyzed are Google Translate, Microsoft Translator, Amazon Translate, Sylendran, and these 4 are commercially available. The other 2 are more academic models. The Ott et al. Talks about, it's a good model for English to French translations. The Edenau one is a winner for English to German translations, right? So, and we selected 8 different languages under 4 different themes. One was Romance language, which is French, Spanish, Italian, and you see the other ones, which are Russian, Ukrainian, Arabic, Hebrew, and German. So the last piece was to how do we actually evaluate and what metrics do we lay out to compare and contrast the gender bias that exists in these systems. So accuracy was a primary metric. It's evaluating what percentage of the instances had correct gender translations. The delta G was talking about the performance difference that exists between male and female translations. The performance difference between stereotypical and non-stereotypical translations are measured using delta S. So for example, when I mean a stereotypical translation or an occurrence, it means that a nurse is stereotypically associated with a female, right? So we want to understand the translations for those occurrences, And we also want to understand it for a non-stereotypical translation. For example, a receptionist is usually associated with a female, but if we want to translate a statement with a male receptionist, how well do these models really perform? Right? So the higher scores are intuitively for delta G and delta S, it indicates stronger biases. Okay, let's just finally dive into the result, right? So on evaluating almost 6 models across 8 different languages, we see that these findings, just to call out, the bold numbers represent that the model is the best accurate model for that particular language compared to the other translators out there. And the underline means that the model performed the most accurate for the particular language. For example, 63.6 for Google Translate means that it performs the best for French translation compared to the other 4 translators. At the same time, for Google Translate, the best translations occur for the French language, right? So the major finding or key takeaway was something that's really astonishing, right? Whoa, what do we have here, right? So the best performing model on each language does not even do much better than a random guess for correct inflection. They're around 40%, 50%, 60% in terms of their accuracy. There's obviously one small exception with German, but pretty much these are commercially available large-scale models, and they have so much gender bias that exists today. We went on to further do other findings as well, right? So we tweaked the stereotypical statements by adding in stereotypical adjectives so that we try to see if these models behave any different, right? So we noticed that once we started introducing stereotype adjectives into these English sentences, the accuracy of the model improved. For example, if I had to just say, the doctor passed the test, for example, right? So here the doctor is a gender neutral term, and in most languages it gets translated to the male version of a doctor. But if we say, the moment you say the pretty doctor, the translations tend to be more female oriented, right? For the majority of the languages. That's what it means in this case. So just to give a further validation on the human touch, we brought in human annotators as well. They were asked to mark the gender of an entity within the given target language sentence. And we quickly noticed that the human annotations was closely in agreement with the automatic method output for almost majority of the languages and systems. So this agreement was almost close to over 87%, right? So that kind of brought in the human validation into our findings and establishing that there is indeed a strong gender bias in the system today. And the accuracy of the remaining 13% in this case was questionable. We went on to further identify what were the patterns. We did some morphological analysis on the sentences and found out that this ambiguous translation sometimes had to do with the idiosyncrasies in the language itself. For example, Hebrew and French have a lot of gender neutral terms. For example, a security guard in French is the same in female or male translation. So those were some of the morphological analysis that we found out. So what is really the limitation on future work? All of this is great, right? We establish there's a lot of gender bias, but where do we go on from here? So today, most of this research work has been around sophisticated, structured English statements where entities are clearly laid out, but that's not the case with the real world. So it starts to question how would these models perform when you start to incorporate real world examples, and that's the model or the data set we want to train on. And then we also start to look at more extensive annotated corpus to improve our training and evaluation metrics. For all you know, with a billion sentences, the accuracy might be skewed towards less gender biases. We never know. So at last, we want to ensure that we come up with research methods to identify de-biasing techniques to altogether remove or eliminate gender biases during these translation times. So in a nutshell, this is the key takeaway. We, through this research, become the first large-scale multilingual evaluator for gender bias in a lot of machine translation systems that exist today. And the research shows that almost all the machine translation systems today exhibit strong gender bias, thus necessitating further research and improvements. If you want to look at our work, our data and code and help us further develop this, It's always available on this GitHub link. And I'm also available through my email and contact anytime you want to connect and talk more about the work. Thank you so much for listening and hope this was an insightful and an interesting presentation. Thank you.